Okay, let's have a look here. Find the local and or absolute maxima for the functions over the specified domain. Okay, let's split the page a bit. Right, 118. The derivative is 2x equals 0. So that means x equals 0. And the y would equal 3. And we should also calculate the ends. F of minus 1 will be 4. And f of 4 is 19. And the second derivative is 2, positive. So that makes that one a local min. So 0, 3 is a local min. It's also therefore a global min because it's a quadratic shape. And then 419 is an absolute, I'm going to call it global max. Okay. 119, the derivative is 2x minus 2 over x squared equals 0. So that means x would equal plus or minus 1. And then we should calculate the ends as well. So f of 1 is 3, and f of 4 is 16.5. And I might need the second derivative as well. But I can see, okay, let's get the second derivative. So the second derivative is 2 plus 4 over x cubed. And regardless, so with the plus 1, it's a minimum. So plus 1 and 3, that's local min. Minus 1 and let's see now, minus 1, 1 minus 2, yeah, and that in the second derivative that's negative, so that makes it a local max. But it's not the global max. Actually, that local min might also be a global min as well, because at the end here, 1, 3, yeah. And then 4 and 16.5 is an absolute max, global max. Let's check the answers if we can. It's 119. Absolute max at 4. Yeah. And absolute minimum at 1, 3. But oh, I forgot the range is 1, 4, so this one is not permitted. Did I make that mistake last time? Minus 1, 4. 0, 3 is okay, and 419 is okay. Yeah, just got to be careful with that. Okay, 120. The derivative is 2x minus x squared, 1 minus 2x, and that should equal 0. So that means x could equal 0, because I could take the x out here and I'd be left with 1 minus x. So x could also equal 1, or x could also equal a half. But it's minus 1 to 1. That's going to include them all. Okay. Then the y's. So if I put in 0, that's 0. If I put in 1, that's 0. And if I put in a half, what do I get? A half minus a quarter. A half minus a quarter is a quarter squared is a 16th. Okay. Now, actually, let's check something here. I'm just wondering if this section includes the second derivative, because I've been using it to determine if it's max or min. It just occurred to me that that might be a skill we're not being tested on yet. Perhaps not, actually, because the examples here are first derivative. Maybe we're not being tested on it. Maybe I shouldn't be calculating the second derivative. Let's just calculate the n's, minus 1 and 1. So when x equals 1, oh, we've done that already. And when x equals minus 1, 1 minus 1 minus 2 is 4. Okay, so that's okay. So that looks like the global max, the absolute max. Okay. And the global min also looks like 0. Well, it has to be 0. So you've got two possibilities, but I'll just go with 0, 0 and 1, 0. That's global min. The 1, 0 also being a local min as well. And the half, need to figure out what's happening at the half, if it's local or global. I think I will need the second derivative, unfortunately, but it's going to require the product rule. So if I don't want to do the product rule, I can look at what's happening in the neighborhood of a half. So you can see that as we go from a half to 1, we're decreasing. And when we go from a half to 0, we're also decreasing. So I'm going to have a stab at saying a half, a 16th, is a local max. So let me see if I'm right. Where am I now? Oh, I like the answers. Oh, it's even. There's not going to be any answer. Rats. Okay. 121. Let's just calculate the n's first. So when x is, no, I'll just calculate the derivative first. Okay. dy dx. So we'll bring down the power, reduce the power by 1, then multiply by the inside derivative, and that's the equal 0. So we could have x is, so I don't care about the minus then, So we get x equals a half. Y would equal a half minus a half squared is a half minus a quarter, which is a quarter. So that's 4. And then at the ends, but actually we can't evaluate at the ends. We're not allowed to use 0, 1 anyway, so we don't have to look at the undefined value here. But we should figure out if it's a max or a min. Now, when this approaches 1 from the left, what's going to be happening here? So it's positive. It's positive. And the other one's positive. Yeah, so it shoots up to infinity. So at the ends, it's going up to infinity. So I'm guessing that this point in the middle would be both a local and global min. And I could use the second derivative to check if it's a local min. The second derivative should be positive, but let me see if I'm right. Yeah, half a quarter. Yeah, success. Okay, that's right. Let me check 119. Absolute max at 4 and absolute mins at 1. Okay, absolute max at 4 and absolute min at 1. At 1? I wrote 0 here. 0, 0, 3. But oh no, I'm looking at the wrong one. Max at 4, min at 1. Max at 4, min at 1. Okay. And they're both absolute. That's a global, and that's local and global. Yeah. Okay. Excellent. Right. 122. Well, I'm gonna cut to the chase here. This is monotonically increasing. So if you look at the ends, when x is 1, we get 1 and root 8, which is 2 root 2. And then at 9, we get 9 and 0. So that has to be a global min. And this one here is a global max. No need for calculus for that one. 123. Okay, so the derivative will be 1 plus cos x equals 0, which means x equals, so that's 2, no, one answer only, huh? Just pi. Cos goes like that. No, pi and, no, minus 1, just pi. It's pi. And that would mean y would equal pi. And if I calculate the second derivative is minus sine x. That's not going to be helpful. So I have to sketch it out. Okay, well, let's calculate the ends actually, because the x is increasing. Okay, pi. Right. And the ends now. Okay. It'll be 0, 0. And then at the other end, it'll be 2 pi 0. But they seem like global mins. I guess the graph doesn't drop below the x-axis. So I'm going to go with their global mins, which means the pi pi must be a global max. Global and local max. Let's see. 123. Global max at 2 pi 2 pi. Oh, 2 pi 2 pi. Oh, yeah, sorry. Did I sub it into the wrong function? 2 pi plus 0. Yeah, that should have been 2 pi 2 pi. Okay, so that's a global min. And that one there is a global max. So then that one can only be a local. I have to figure out if that's local or minimum. Let's think about what's happening. Slightly to the left of pi, this is both decreasing, and slightly to the right, it's decreasing. Could be a saddle point, possibly. Could be a rising saddle point. Let's check it out, figure it out. So yeah, we said the second derivative. First derivative was 1 plus cos x. The second derivative is 1 minus sine x. And if we put in pi, what will happen is we'll get 0 here. So we'll have to look at the third derivative, which will be minus cos x. And then if we put in pi for that, we get a positive, which makes it a rising saddle. Okay, let's see now. Right, 123. 2 pi 2 pi absolute max. Yes, I got that right after my screw up with the subbing in the value. Minimum 0 0. And then that's it. So they don't want saddle points. They only want maxima. That's funny. They only want the maximum. So I guess I'm doing more work by looking for the minimum. But the answer at the back includes minimum. So I guess they meant maximum or minimum here. Yeah. Okay, so yeah, you can delete that one then. Okay. 124. Okay. Running a bit out of space. How are we doing for time? Oh, maybe we should wrap it up there for today. So it's already about 20 minutes. Yeah. I'll show you a little trick here for 124. So if we were just to put in 0, we would get 0. And if we were to put in 100, we'd get 100 over 101. So I think these would be globals. We can't go negative, so that has to be a global min. Question is this a global max? I think that is a global max. Because if you think about it, if you had like x is 1, this would be 1 over 2, or 2 over 3, or 3 over 4. So it's asymptotically going towards 1. And there's no, I doubt there's any locals, because if you calculate the derivative here, you'd get the bottom squared, and then it's the bottom times derivative of the top minus the top times, minus the top times derivative of the bottom minus x. So you can't get this equal to 0, and the value when it's undefined is not included. So that's not going to be equal to 0. So yeah, as I thought, it's just global min and global max at the ends. 124. Yeah. Okay. Now, interesting. Very interesting. Actually, this will be a good place to stop because the next time now, from 125 onwards, starts with a very interesting question. So, yeah, okay. 118 to 124. Thanks for watching.